Hello, welcome back to the second video in this circle series. So this video, we are going to be looking at points in relation with a circle. So this video, we're going to be going over how we can find out if a point lies within a circle, or it be on the circumference of a circle, or it's outside a circle. So how do we do this? Well, let's just imagine we have a circle here. So I have a circle here, and I just put a point here, right? Now, obviously, we can see that this point is in the circle, yeah? But sometimes we're not given a diagram of the circle, yeah? So we need a little mathematical method of figuring out if a point is on or in or outside a circle. So if we look here inside the circle, right? Something we know, again, about circles is the point from the center of a circle to outside the circle is called the radius. Yes, it's called the radius. And what we know is, look at these two lines here. Well, from here to the circumference, the length is going to be equal to the radius. From here to here, this point P. So from the center point to a point P. What can we say? Well, this has to be less than the radius, isn't it? So what we can say is, if the distance from the center point to another point, if it's less than the radius, it lies within the circle, right? And again here, I have a point. I'm going to put a point here, right? The distance between this, from the center to this point, well, that's going to be the radius, isn't it? So if the center point, the distance from the center to the point we're asked about, if it equals to the radius of the circle, then we know the point lies on the circle. And then finally, here I have a point outside the circle here. I can see here this distance extends my radius. Yes, it's bigger than my radius. So we can say if the distance between the center point and the point we're given is greater than the radius, then the point lies outside the circle. So we can do this two ways. We can use our equation of a circle, or we can use the distance formula. So I'm going to show you both methods now. So here's a question. Are the points 1 minus 3 and 3 minus 2 inside, outside, or on the circle x squared plus y squared is equal to 13? So, looky here. I see, well, my equation of a circle is in this form. So therefore, I have a center of 0, 0. So I know my center point is 0, 0. So I have my 2 points here. So I have 0, 0, my center point, and I have my 1 minus 3. So let me label my points. That's going to be x1, y1. Let me write them out here. So 0, 0, 1 minus 3. So x1, y1. x2, y2. So I'm going to use my distance formula. So d is equal to square root x2 minus x1 squared plus y2 minus y1 squared. So the distance is equal to the square root of 1 minus 0 squared plus minus 3 minus 0 squared. The distance is equal to 1 squared plus minus 3 squared. Distance is equal to 1 plus 9, which is equal to the square root of 10. So the distance between my center point and this point is equal to the square root of 10. So let's have a little looky look now of what my radius of the circle actually is. So I'm going to go back up to my equation here. So if you remember in the previous video, we were able to extract what the equation what the radius is from my equation of a circle. So we see here, so I'm going to write down my general form here. So x squared plus y squared equals r squared. So let me equate the 13 and r squared. So r squared is equal to 13. Or is going to be equal to square root 13. So my radius is going to be equal to square root 13. So let's compare that now to this distance point I got here of square root 10. So is it bigger? Is it greater than, less than, or equal to? So This is actually root 10 is going to be less than the square root of 13. So you can put in your calculator and change the decimals, or you can square both sides and get 10 is less than 13, which still holds true. So I have 10 is less than 13, so therefore, right, therefore, so my three little dots here, therefore, this point lies in the circle. So it lies in the circle. Right, let me do the second one here. So again, I have my center 0, 0 because I got it from my equation here. And I have the point 3 minus 2. So let me label my points. x1, y1, x2, y2. Put in my distance formula. So I'm going to have 3 minus 0 squared plus minus 2 minus 0 squared. So my distance is going to be equal to 3 squared plus minus 2 squared. D is equal to 9 plus 4. D is equal to square root 13. Hold on, wait a minute, hold on. My distance here from the point 0, 0, my center point 0, 0, to the point 3 minus 2 is equal to square root of 13, which is equal to my radius. Right, so since my distance is equal to my radius, so since square root 13 equals square root 13, therefore, this point lies on the line. Right, so it lies on the circumference of the circle. So then, when I was saying the other point was, what the other point was, or the other method we could do is we can use our equation of a circle. Yes. So again, like how in my previous video, I used the equation of a circle to find the radius with it, when we have a point on the circle. So investigate if the point minus 3, 4 is inside, on, or outside the circle. So basically what I do here, if you look above, I'm going to sub these points in, and if it's less than 16, it's going to be inside. If it's equal to 16, it's going to be on. And if it's greater than 16, it's going to be outside the circle. Right? So if it's less than or squared, so if it's so basically, if the left-hand side is less than the right-hand side, it's inside. Left-hand side equal right-hand side, it's on. And if the left-hand side is greater than the right-hand side, it is outside. Got it? Cool. So, x, y, I have minus 3 squared plus 4 squared equals 16. Minus 3 squared is 9, plus 4 squared is 16, equals 16. So I have 25. Right? 25. What's 25? Well, 25 is greater than 16. So therefore, since it's greater than 16, it's going to lie. So this point is outside the circle. And this point is outside the circle, ladies and gentlemen. And that is how we find if a point is inside, on, or outside a circle. So, good morning, good evening, and good night. And I'll see you very soon. Bye.